there's a lot of concern that, well, we don't know exactly the state of these large upper stages, after being in orbit and in radiation environment for so long. Maybe they're very brittle, maybe they'll come apart when you grab them. People are going to want to know that we have, or not us really, we're not going after them, but the companies that are doing the active debris removal will have the technology to contain the object from doing something bad because they touched it. If the owner of the object has an avenue for offloading that liability, I think it creates a new incentive, economic incentive for them to agree or even pay for this transaction. So they may pay us to process their space debris. As many recycling outfits get paid to take electronic waste or whatever, there may be a market from like the insurance companies and other governments even to and these individual companies that have these liability risks to pay us to take this off their hands. So the law has a lot of, it could create incentives, it could create disincentives. I think right now, under the current rubric, we can operate the business.
We are back with another episode of the Cold Star Project. I'm the host, Jason Kanigan, the founder of this thing, Cold Star Technologies, and I'm here with Gary Calnan, who is the co-founder and CEO of CisLunar Industries out of Denver, Colorado. Thanks for being here, Gary.
Yep, thanks for having me. Appreciate to be here.
You bet. So I wanted you on because of something in your LinkedIn profile that was very specific. You said, we are about, at CisLunar Industries, creating industrial capabilities in cislunar space that will enable sustainable space exploration and a permanent human presence beyond Earth. So we're going to get into a little bit about what that means, how you define it, and what you have to do in order to achieve it. So my first question is, at what point or a number of human beings does a permanent human presence beyond Earth exist? When can we say that's actually a reality?
Yeah, I was thinking about this, and I mean, I think it's not so much a number or I mean, if you think about it, we've had a permanent human presence beyond Earth's atmosphere since the space station's been in orbit, technically. So we're already doing it, but on such a small scale that if funding stops for the space station, that presence is gone, right? So it's a bit like an outpost in Antarctica or something like that. It's not self-sustaining. And when I think about a permanent human presence beyond Earth, we think about colonies and settlements either in free space or on the lunar surface or eventually out into Mars and beyond. And for those to occur, you need enough people there who are doing something that creates value that causes them to want to stay there on a permanent basis. And once there's that critical mass, and what that number is kind of hard to define, I think, at this stage, but we'll know it when we see it, and you certainly see it in plenty of science fiction. Mm-hmm. I think it really comes down to the economics of the situation and whether there's enough activity happening that would cause somebody to want to be there on a permanent basis.
Okay,
there's
that makes a lot of sense.
You can be somewhere on a permanent basis. It's either you have enough money that you can just pay to be there, or you have some economic activity that's giving you revenue and adding value to the economy that you can produce things to stay there.
Okay. So the folks at the von Mises Institute are going to be very happy to hear about the economics of this. Is important, and it's not just going to be grant funded or something. And I'm hearing also something about resources and creating your own resources, I think, seems to be an important thing here. It's not we're getting this stuff shipped in all the time to keep following this effort. We're able to do it ourselves. Okay, so let's move on from that then to what you mentioned, this phrase, industrial capabilities. So what are those? What do you believe needs to be developed first?
Yeah, so you just mentioned the resources thing, and that kind of underpins the whole development of the industrial capabilities in my mind. And that's really what drew us to the business that we're pursuing right now. But, when we think about how do people move in a permanent fashion from one place to another, they need to be able to have the resources there, what they say in situ or in that location, to be able to support those people and the economy that's there. And in order to think about what industrialization has to happen first, you think about what resources need to be created. So when we think about this lunar state, I mean, a lot of people are going after water, which makes a lot of sense, right? The asteroid miners see water as the lunar miners see water as sort of the oil of space. because it supports human life, it supports fuel production, and those things will be, I think, the underpinning of the beginning. But when we were looking at the whole value chain, you think about building up a full economy that's sustaining, you need to have an industrial base to be able to sustain those people, to build materials for them to build habitats and devices and whatever they need. Basically, is going to need an industrial base, just as you have in any other economic development period throughout human history. As we've expanded, we've set up industrial bases where we go, and this is going to be no different in our mind. And so, we see resources as underpinning it, and then what resources can we acquire in space, and then what industries can we develop to use those resources. So water is first, I think, but then we see metal as being a key component of that. And that's why we developed CisLunar Industries, to sort of go after ways that we can process those metal resources, which to us seemed like an under focused area at the time anyway. And so, I think that's how it gets started. I don't know if I went a little bit off the tangent there, but yeah.
Yeah, I'm very happy to hear about this. And you are, I will call you a numbers guy. You have the letters CFA after your name. Take a moment and explain what that means.
Yeah, CFA is a Chartered Financial Analyst. Essentially, for people who aren't in the investments industry, they typically don't know what it is, but it's a postgraduate designation that you get for, it's sort of like a CPA, but it's for analyzing equities and investments and doing financial analysis for that sort of sector. So I have in my previous life, I was in a finance role, and I also was working for an asset manager, and I ran portfolios and developed strategies and that sort of thing.
Right. So I really want folks, listeners, to understand that you're approaching this from a business, financial viewpoint, an economic viewpoint, which I appreciate a lot. My background is in business administration and operations management, so I care about this stuff. It's great to produce capabilities, but if they don't make money, nobody is going to exploit them and do anything about them and expand.
Right. So yeah, I think that is one of the that is one of the differences, I think, from what other investors and people we've spoken with in the industry have told us, that our approach did not emerge from a technology that we had created and thought was cool. We looked at it from a high level perspective as to what is needed, as we just discussed, to create this future state, and where is the gap, and how can we fit into that and create value. So that does take that different sort of business approach towards the problem. Right.
So water for fuel is important, hydrogen and that, but metals are also very important too, and not to bring back to Earth. Anybody who read the classic Asteroid Mining 101 knows orbital infrastructure and making stuff in space rather than having to kick it up out of the gravity well and put it in orbit, which is very expensive. Just go get it and then use that to produce new things in space. And so let's talk about this Space Foundry idea that you have, because you're talking about, okay, we've realized that the economic idea of space is underserved on the metals area. Everybody's rushing towards the water and hydrogen usage. What about the metal? And then what capability do you need to create to be able to use it?
We were looking at the entire value chain of space resources. And we saw the processing metals was an area that was not really being pursued yet. And we were kind of thinking about, okay, there's asteroid miners on one end, they're going to bring the materials to us or somebody. And then there's companies like Made in Space and others that are doing in-space manufacturing, and they can use the materials to build things for this future economy. And so what is needed in the middle? We need somebody who can take those materials that are being produced and process them and turn them into the finished goods or input materials for that manufacturing process. And what we were, as we looked at this problem, we also became aware of, and I was kind of coming to this whole space sector as a newbie, but we became aware of space debris as a problem as well. And we saw an opportunity there to kind of join these two concepts. We know we have a problem with space debris. We know as we continue to increase activities in space, space debris is going to become an increasingly necessary problem to address. And we have this other idea that we want to accelerate the progress towards this, humanity moving beyond Earth. And for that, we need this industrial base. And so maybe we can look at space debris as a possible resource to use to put into this idea we had for processing metal. And you asked about the Space Foundry specifically. So, that that as a possible source of feedstock did kind of inform how we would need to develop this Space Foundry concept. And our idea is that we will go after space debris first and develop this capability with space debris. And then when the asteroid miners are ready to bring materials into Earth's orbit or cislunar space, we will already have developed the technology to be able to process it. We'll be in a good position to do that. And so thinking about space debris as the feedstock for the system, we thought, okay, well, what will we need to do to it? We'll need to take it apart. We'll need to sort of make it smaller, melt it down, kind of reformat it so that it can be turned into something that can be used for manufacturing. And if you're thinking about 3D printing or something like that, then you might need to be able to make like a wire filament for 3D printing, or I mean, you really wouldn't use powder in space. That has, for obvious reasons, there's gravity could become an issue with powder floating around. But metal wire is possible, and we could also actually directly manufacture things like trusses and other sort of dumb objects that don't have circuit boards or any of that sort of thing, but do need to be large and could be used to create structures and underpin some of the other technologies that could be more easily boosted up from Earth in the beginning. And to do that, we know that we have to melt something down. So we looked at, okay, how are foundries done on Earth? And you have a crucible, and as we talked to people who were, we spent a little bit of time kind of understanding what that looks like on Earth, and those systems need to be maintained a lot, right? They have those surfaces. They get eventually they get fouled up, or they could, and you need to replace them. And that's obviously a problem in space unless you've got another factory that's making crucibles and you've got people there who can do it. But we imagined a free-flying robotic platform that would not really be human-tended because it's way too expensive to have a human where it's not necessary. And so we looked at what kind of technologies, and also we have microgravity. So you have another challenge where you're not pouring things into a crucible. So we looked at electromagnetic levitation as the possible answer here. And the idea is that, you can, inside, they do this already in the space station, by the way. They do it on a small scale. So this is not totally new technology. But you can basically place a metal inside a magnetic field and it will levitate, and the same fields can be used to heat it up and melt it. And that allows us to create that molten material. And then we imagine using the same basic technologies to extrude it and sort of manipulate it into a new shape. And that was the core concept behind the Space Foundry, was this electromagnetic levitation furnace and electromagnetic levitation extrusion system, which would be relatively unique, actually.
Okay, and you have put in a proposal to the ISS National Lab,
right?
To I don't want to say create this technology, prove it, I guess, and demonstrate that you can do it on this scale. So tell us about that.
Actually, we originally went to the ISS National Lab with the idea to put what we called the Space Foundry Laboratory on the outside of the space station. And so we had envisioned like a smaller scale version of this Space Foundry furnace that could process larger balls of metal than they're doing in the current furnace, for materials research, which are right now they're like 8 millimeters in diameter. So we were thinking something maybe the size of a golf ball that could be then extruded into longer objects, and we could actually produce something with it. And we proposed this idea. It was, relatively expensive to put this whole thing together and then have it hosted on the outside of the space station on something like the Airbus platform that's going up. And so they came back to us and said, we love the idea of using space debris as a resource and not as just a problem. And we like this sort of approach to, linking that with in-space manufacturing. But can you do something a little smaller that's not so, ambitious for the first project you do in space? Because we're a startup. We have, we're just, a lot of us are kind of relatively new to the space sector, and they want to see that we can actually pull something off first, which makes sense. And so the team kind of put their heads together, and we thought, well, let's take the whole system, break it into its process parts, and see, is there one piece of this that we can prove, some way in microgravity that will help to elevate the TRL level, the readiness of the technology, and move the project forward and make it less risky to do the full-size Space Foundry laboratory. And so we came up with this idea to use liquid metal. And so most people are familiar with mercury as a liquid metal, but it's toxic. You don't want to have that with the astronauts if you don't have to. It turns out there's another alloy, or there's a metal called gallium, which is kind of liquid if you hold it in your hand. It has a very low melting temperature. It's not toxic. And you can mix it with other elements like indium, and I think tin is the other one. And it makes this alloy called Gallium, which has a melting point of right around freezing. It depends on how you make the ratio. So you can go from minus 11 degrees Celsius up to, I think it's like 55 degrees. So there's different ranges of temperatures that depending on the mix. And our idea is that we can use a liquid metal Gallium to show that we can use those electromagnetic fields to not just control it in one spot, which is what they do already, but also kind of stretch it out, make it into a shape, maybe show that we can precisely move its location within the furnace, push it through a die where it's, we have a physical die that we can push it through so it makes another shape coming on the other side, and even possibly stretch it out and then lower the temperature in the chamber and freeze it in place to sort of simulate, molten metals cooling off and turning into something that we produce.
Interesting.
And this can all be done, we think, on a small scale inside a NanoRacks module, but we can do it relatively cheaply, an order of magnitude cheaper than the other experiment idea. And it sort of satisfies that idea of that need to kind of do it quickly, lower risk. And also what's kind of cool is because we're using this liquid metal, we can even do this on the ground and sort of put the metal on a plane and play with it with the same magnetic field. So we can do a lot of the testing, without having like parabolic flights or other microgravity simulation environments to show that the math works around it. And we were able to partner with the Colorado School of Mines and their Space Resources Department to work on this, as well as another guy in the Mechanical Engineering Department who has a lab where called M3 Robotics. They use magnetic fields to control other objects with magnets in them remotely. So it was the perfect blend of skills to do this exact project. We can use his experience with the algorithms to kind of accelerate our progress with this idea. But we just submitted this proposal yesterday. If I look tired at all, that's why. But it was an intense process to get that out the door. But it's in, and we'll see what they say. We should find out hopefully within the next couple months.
Right. I'm curious how much energy this manipulation takes, and what the power source is for that.
Yeah, so to hold a piece of metal in a certain position in microgravity takes very little energy because you're not fighting the gravitational field. So levitating it is just a matter of holding it. It's almost negligible how much energy it takes to hold it in place. To melt down like steel and aluminum on sort of a grander scale, I don't remember the exact numbers for the Space Foundry laboratory that we have. I can tell you that this experiment that we're doing with the liquid metal, we have 500 watts available to us. So we're going to operate within that envelope and figure out a way to make it work. Just might be a matter of scaling the size and whatnot to get that to happen. But when you melt actual metals, it takes quite a bit more power. Now, by comparison, the electromagnetic levitation furnace that's on the space station right now runs at about 2,000 watts. So that's to melt a very small piece of metal pretty quickly. We were going to operate in a 1 kilowatt size constraint on the outside of the space station with our Space Foundry laboratory. And, we doing the math, we believe that it could be done. It's mostly a matter of time, not so much, power at that state. You have to get above a certain level, but once you're there. To do the industrial level stuff that we had envisioned for the full scale Space Foundry, we scoped out a project for a sort of a free flying satellite, kind of a ComSat size satellite that would process up to 5,000 kilograms of material a month. And for that, we needed around 30 kilowatts of power. And so we were, you can do that with solar panels, but they're big, but you can do it. So that kind of gives you a range of what we think.
It gives me an idea. My original thing out of college was with industrial gas turbine generator sets and diesel power plants up to 5 megawatts, 20 megawatts, that kind of thing. So I'm getting a picture here. Is it like solar power and battery, or is it a chemical engine, right, where you're converting a fuel source into something and then it, into electrical? So, okay. So that gives us an idea. You can use large solar panels that will power batteries and that will come out and do that. The manipulation is pretty easy of physical location. The melting down and reshaping takes a little more power, but it's not massive amounts. I'm not hearing like, huge
Right.
fires of Mordor, kind of thing here, where you need a massive power supply or fuel supply constantly being provided. So it is renewable, which is part of your charter, so to speak.
Yeah.
And I like that. Okay.
Well,
So
one thing to keep in mind, though, when you talk to people who are in the metals industry on Earth, first of all, 5,000 kilograms a month is like nothing. Okay, they're doing, I don't know, hundreds of thousands of tons a month. So it's a totally different scale when you get to an industrial scale like that. And the power for those those kind of devices on Earth is obviously proportionally larger. So when I think about like future longer term future states, if you get onto the surface of the moon or something like that, and you've got megawatt scale power available from a nuclear plant or whatever, it's conceivable that you can scale it up, because a lot of it has to do with the more power you put in, the faster and more you can melt. So it's just kind of a relationship in that. So, but for our purposes and for processing space debris, that's a fairly decent amount of production.
Okay, and I really like that you got Colorado School of Mines in there. I mean, obviously they're closer to you than many other things, being in Colorado. Dr. Chris Dreyer is going to be a guest on this show.
Good. Yeah,
March or April or something, and I had a chat with him early on, where it was great, because that was one of the chats where I noticed like how much I had learned. In that I was like, I wouldn't have been able to have this conversation with you 2 months ago or something like that, 3 months ago.
Right.
So it's a learning process. So I know how you feel about like the space thing and having to learn. There's so many things. I bet you never thought you would be learning about chemistry and that,
Right. Exactly.
This is Jason Kanigan from Cold Star Tech, and I'm excited to share with you a new offer from Cold Star that we are bringing out to help both space founders and venture capitalists who fund space companies. And it's on two levels. The lower level is a VC who is looking at possibly funding a space company, but they just don't get it. All right? And a lot of tech founders want to come out and create some sort of technical capability, but they do not understand business. And so you'll look and you'll go, where's the customer here? Where's the business model? And they'll go, but I want to make rockets or something, right? And it's really cool. Well, that, as we know from the dot-com era, is not a viable business model. And so you bring us in. We've got great technical expertise on the space side, folks who have done this sort of assessment before, like our technical engineering advisor, Dr. Rick Fleeter, myself in the process engineering field, plenty of other people with brains to look at this problem so that you don't have to blow your brains out trying to figure out how to make this work. And on the company side, it's a benefit for them because we will show them the roadmap to how you're going to get funded, how you will want to fund them, what changes to make to get VCs excited about putting money in. And so that's good for you. Right? The second level is at a deeper and higher level at the same time. It is for venture capitalists who have given a seed round to a company, a space company, and that has gone on for a little while, 6 months, a year, something like that. And it is time, as COVID has made it, to double down or get out. Those are pretty much the choices, right? It's time to invest further in a thing we already know, which seems to be the direction VCs are going in right now. They don't seem to want to look at new things or stop, just kill the project. And so the good news is, in that situation, there's a lot more going on. There's more meat for Cold Star experts to get in and analyze, right? You're going to have processes in place, whether they know it or not. We'll be able to flowchart those and maybe accurately document them for the first time so we can get some kind of value chain going in the organization. We'll be able to test whether the leadership is the right group of people or whether you're missing something, the strategic direction, the business model, all this stuff. So if this sounds interesting to you, reach out to us. You can email me at jason@coldstartech.com or just connect with me and message me on LinkedIn. That's probably the best way to do it. And I am excited to talk to you. The kind of transformation that we're able to offer here is beyond anything you'll see out there. And as a VC, this will save you so much time and energy, right? Like if you're a VC and you've got 100 companies to look at, you've got 3 days a year to look at each one maybe, right? That's not really good enough, is it? Wouldn't it be better to have experienced, expert space people who understand space, right? Look at this investment and tell you, here's a grade. Right? Here are several grade areas. Is this thing ready to pour gasoline on the fire, or is it just going to go up in smoke? This is Jason Kanigan from Cold Start Tech. Let's get back to the interview. So I'm curious, let's move on to the legal issues of capturing and recycling objects and metal things already in orbit. How are you going to handle that?
Yeah, it's an interesting topic because we actually spent a good chunk of the first, year or so talking to experts about various things to make sure that it was even possible, both from a physical and from a regulatory standpoint. And the legality is a bit, so for mining resources off of a planetary body, that's kind of been figured out to some extent, especially with the laws in Luxembourg and the United States and other countries that are talking about doing this. It's sort of cleanly within the rubric of the Outer Space Treaty. When you get to space debris, it's a bit trickier. And a lot of people who come to it, without knowing about the rules here, kind of assume it's going to be like salvage. Like, can't you just go salvage in a derelict object like you do in the ocean? But that law doesn't exist in space.
Right.
All we really have to operate from is the Outer Space Treaty. And technically, it's, whoever launches an object into space is responsible for and owns that object until it disintegrates. Either by
and the
nation
state that they belong to as well.
Yes, exactly. So many of those objects that are up there presently are owned and were launched by nation states. So a lot of it is you're dealing with nation states. But even though that's the case, and actually in some ways because that is the case, the idea of us going up and getting space debris is kind of clear in the end, because we know that we can't just go grab it, right? It's not free to grab unless the law changes, and this is a treaty, so I don't really expect that to happen unless it's already happening. So we assume that we are going to have to go and talk to the government that sponsored the launch originally, as well as if there is a company that owns the object, that company as well, to get permission. And we'll have to demonstrate that we will, and also we'll have to get permission from our licensing state to go do this activity as well. So there's a lot of coordination potentially between multiple nations, as well as commercial owners of the objects. And we have to be able to demonstrate as well that we can. There's going to be some new ground broken too, because no one's really done this sort of transfer of title for an object that's not functional. There have been satellites transferred ownership because the company is purchased or whatever. And in one instance that I know of that was told to us by an expert in space law, I think it was Hong Kong or some nation actually did change the registry of an object by the nation state to another nation state.
I just thought of that question. Yeah.
It hasn't been tested though. So all these things, you could try it and we could do it and probably get no objections from the UN. But if there's an accident, let's say that, so we also have a Luxembourg company. We have a Denver company and a Luxembourg company. Let's say we were licensed by Luxembourg. They obviously have less capability to pay for damages than the United States, for example. And so if there is an incident, who is the aggrieved party going to go after? That is an open question. It's a risk that our launching state would want to take into account before agreeing to license the activity, right? And some of these objects, there's a lot of concern that, we don't know exactly the state of these large upper stages, after being in orbit and in radiation environment for so long. Maybe they're very brittle, maybe they'll come apart when you grab them. So as people are going to want to know that we have, or not us really, we're not going after them, but the companies that are doing the active debris removal will have the technology to contain the object from doing something bad because they touched it. Right. On the other hand, if the owner of the object has an avenue for offloading that liability, I think it creates a new economic incentive for them to agree or even pay for this transaction. So they may pay us to process their space debris, as many recycling outfits get paid to take electronic waste or whatever. There may be a market from like the insurance companies and other governments even and these individual companies that have these liability risks to pay us to take this off their hands. So the law has it could create incentives, it could create disincentives. I think right now, under the current rubric, we can operate the business. And in theory, there's nothing that would stop us from doing this. We just need agreements from people.
Right.
I mean, I say that like as if it's, super easy, but, it'll probably be harder than I imagined.
The first thing that I thought of was you're going to need a sped up process to
Yeah.
discuss these title transfers, and there was at least one more factor involved than I originally had thought. After you explained it, or as you were explaining, I was like,
Mm-hmm.
I hadn't thought about that. So yeah, it is a little more complicated. It's not just buyer and seller, if you will.
Right. Right.
And for those interested in the insurance side of space, I recorded an interview with Bob Weirdy in December that hasn't been released yet, but probably by the time this comes out, it will have been released. So you'll be able to look at that. And Bob explained the whole insurance field for space and how it works and that. So it was very cool.
Yeah.
Okay, so there's some complexity, but it's not so bad. And for those thinking, as everyone does, including me, when I originally got into it, well, isn't space law just like rooted in maritime law? No, it is not the same. Salvage does not work the same way, and the rules need to be figured out. And it's kind of good. The interview I did with Laura Montgomery, who's a space lawyer, we really got into that. It's kind of good that there is that gap or delay in terms, that things are not cut and dried right now, because they need some operating time. The operators need to get up there and goof up a little bit to create situations, because it's kind of impossible to predict every possible thing that could happen. And go, okay, yes, we definitely know what the answer is here, and here are the rules.
There's no way, yeah.
Like, no, let them get out
there. There's a big risk of trying to anticipate the challenges and, too much and create regulations up front that they could stifle, innovation and activities that could possibly create solutions. So, yeah, I think you're right. The gray area that exists in the Outer Space Treaty is sort of giving a lot of room for things like the laws that the U.S. and Luxembourg passed to, legalize asteroid mining, for example, and by the same token, mining resources on the moon. So there's not always agreement from all the different parties that might be involved in those treaties that should be allowed. But it's kind of like, it's not quite as bad as sort of the Uber model of just go and do it and then figure out the rules later. But it's a little bit like that.
Well, I know I've been told that the European space folks definitely want things written down and agreed upon a lot more than the American side, where we're more, hey, just let it go for a little bit, let's see what happens. So what do you think that it will take, Gary, to reach a point where in-space manufacturing and construction is just ain't no big thing, we do that now?
Yeah, that is like the $1 million question, or maybe $100 million question. I mean, in fact, this is a question that's kind of come up with investors and advisors and mentors that we have a lot as well. You get a bunch of space people together in the room, and we participated in the CDL space stream for a few sessions as well, and that was what happened. We got all these space people in around a table, and you can say probably to a person, everybody there agrees on, or sort of thinks that this O'Neillian future of space habitats and, settlements is going to happen eventually someday. We all can kind of see it, right? But how do you get from here, where there's everybody who is a customer of any space activity right now is a human being on Earth, and to this future where you've got a whole economy of people out, who can use things out in orbit. And, sort of like a government-driven, let's go colonize space kind of initiative that might only come about in a competition between global powers, I think you need to have a more bootstrapped approach. And as a company and a startup, we can't count on government action. So we have to think about what's the path forward that, maybe we can leverage government action where it's there, but that's going to get us to this future. So what is it going to take to get to this state where in-space manufacturing is commonplace? I think we're starting to do it. So you need some government support. I mean, I don't think we're going to get away from the fact that, we need something to underpin this marketplace in the beginning. If you look at companies like Made in Space, for example, they have basically proven that at least NASA has enough interest in furthering in-space manufacturing to back their current demonstration of the Argonaut, which will do in-space manufacturing on a much larger scale than has ever been done, and with different materials than just like normal 3D printing plastics. But I think it's going to take that in the beginning, unfortunately. I wish there was just a big marketplace of people who are chomping at the bit for in-space manufacturing. But unless you have buyers in that market, and who's the user for things manufactured in space? Well, if we think about large-scale objects, or different missions that you can fly because you're manufacturing in space and not building on the ground and launching, then it's the people who fly missions and who are doing things in space. And even though launch has become heavily privatized, a lot of the customers for launch are still governments. So I think that for the foreseeable future, at least from our point of view, we expect support for our endeavors to come from U.S. government entities and maybe other government entities that want to see these technologies develop because they see a strategic advantage for either the space programs and space exploration to having these capabilities developed, or they see a strategic advantage from a national defense perspective to knowing that our country has this ability to compete with China or whomever that also wants to develop economies in space. And I think that competition there is actually going to help to drive things forward. I mean, the timing is totally unknown, really. I mean, I think it could be as soon as in the next decade. It could be longer than that, depending on how things unfold and how the global economy performs and everything. But along that path, with this support, there are opportunities to start to add commercial activity. So you've got, for example, we've got the efforts to privatize the space, not the space station that's existing, but build private space station modules. Those are going to start by attaching to the space station. I think I just read that Axiom got the first contract to attach to the space station. NanoRacks also has a proposal for building modules out of upper stages. And then, the way NanoRacks painted the picture in their document, which we really agree with, is that you start with that one, then you string along, other outposts in the same orbit as the space station, because you've already got the infrastructure being launched to the space station. Once you get up into that orbit, moving along the orbit is actually relatively cheap. So you can set up those outposts and not have a lot of expense having, a space tug go from this one to this one if they're all in the same orbit. And that way you can move some of the activities that need to be manufactured where there's better microgravity than you can get on the space station to another complex. Maybe one of those complexes for us is one where you have a Space Foundry on one end. You have, we don't start with going out and getting space debris from lots of different places, but you use the upper stages that aren't being reusable as the first test case, and you process some of those and you feed them into, a made in space, and made in space uses that material to make objects that can be like parts that can be used to assemble into, say, a satellite that can then be launched from that space station orbit. And the more technical components are still brought up from Earth, but then you have a customer at the end of that value chain, somebody who wants to launch a satellite. So you have to build up this value and then show that it's much cheaper and you have better capabilities by doing it that way than to bring it up from Earth. There's also the idea that if we can come up with some materials that can only be made in microgravity, and there are definitely unique environments there that could be done. Z-band, this fiber cable that Made in Space is working on and others are working on, is one of the most obvious examples of where it's actually worth it to make it up there and bring it down. But we don't know what they are yet from our perspective. But we think that there will be discoveries of other materials that are worth bringing back down to Earth. And so there's also a market in the beginning, potentially. And then there's even just like marketing and that sort of aside revenue streams to that, like, for example, they did the baking cookies in the space station and DoubleTree Hotels sponsored it. What does DoubleTree Hotels have to do with cookies and space? Nothing, but space is cool. And, it gets them some interesting exposure for their cookies, which is a branding thing. So there's all these different ways to get it there. But the way I see it is we start with those paths. This could occur over the next, 1 or 2 decades. And you've got companies like Orbit Fab that are building, gas stations in orbit. And with the gas stations, that makes it possible to actually go to other orbital planes and go bring the space debris back to another location. And we start to build up that infrastructure. And the more activity that happens, the more use cases there are for building structures and bigger platforms. And then the costs come down. And it has this sort of virtuous spiraling effect. And then you throw in the mix, if there is a real push, if this comes to fruition, this push to the moon, to start establishing settlements, there will be obviously government funded in the beginning, especially if there's competition with China and other nations to get there. That could add a whole nother reason for making things in orbit, because make it up there is cheaper to get it up there. And these same capabilities can be used on the lunar surface for sustaining those settlements. I think it's going to take that path to get to the point where making things in space is commonplace. The other thing that people have brought to my attention that I didn't think of when I first got into this was, because I didn't know about the aerospace industry that much, was that people who make things in space really care about the provenance of the materials. Like, they really want to know that the materials they're getting are pure or high quality. And how do you verify and validate that in orbit? And so you can to some extent, but not to the level you're going to be able to do on Earth, right? And so there's what's going to take us to get to where it's commonplace, I think, is going to be somewhat of a paradigm shift in thinking where, it's cheaper enough that it's worth taking the risk that maybe the materials won't be as perfect as I'm used to them being. And as people get used to that, being a way to get materials made and used in space, then they'll become more comfortable with it. And then again, eventually it becomes commonplace. So
yeah, that is something I haven't thought of either. Quality assurance in space, basically.
Yeah. Probably a whole business around that, actually.
Yep, that is something that this company could do. Interesting. Hadn't really thought about that. Well, my final question then is, I'm just reading it and I'm like, it's kind of a gimme. I mean, how else is he going to answer it? But I'm curious. Okay, so we're developing manufacturing and refueling capabilities on the moon. That is happening, right?
Yeah.
You've got Artemis, you've got guys like Dr. Joel Sercel talking about lunar ice mining and that kind of thing. And that's going to impact in-space efforts. What you're talking about, orbital, the Space Foundry and creating stuff in orbit, and that is also going to impact in-space efforts. Which do you think is going to be more impactful in the near future?
In the near future, I mean, if the Artemis program goes forward on the schedule that has been proposed, that for sure will have a massive impact on this stuff. I mean, as the proponent of my own idea, of course, I would love to say Space Foundry is going to be the most impactful. But to be honest, I think the big market really is you need something that really anchors the whole activity. And successfully extracting water ice from the moon or anywhere else for that matter, and bringing it to cislunar space, cislunar economy in a deliverable fashion that can create this fuel economy in space, I think that will probably power a lot of what's happening. That, and also just sort of the imperative to get things set up on our side versus the other side, but which. I would love to be in a situation where we all collaborate and do it all together, but, I know how, politics works. It seems like having those incentives, that competition can sometimes be healthy in some ways, can drive progress forward. So yeah, I actually think that the lunar mining is very exciting. And, we think that we can take our activities to the moon too. So I want to see a diverse, well-developed economy that has reason to be there and customers that exist where we want to be, and then the markets are there for us to supply them with materials.
Right. That makes a lot of sense. Gary Calnan, co-founder and CEO of CisLunar Industries out of Denver, Colorado, and Luxembourg. See,
that's right.
Just listening. Where can people go to find out more about you and your company?
Yeah, so we have a website. It's pretty limited right now. It's basically a landing page. That will change as we start to work on some of these projects. I would say the best place to find us is on LinkedIn. I'm on LinkedIn. You can find me there. You can also email me. I'm happy to engage in discussions with people who want to know more about this idea. You can find me at Gary at CisLunarIndustries.com. And again, like if you ping me on LinkedIn, I'm always on there. So. Yeah.
Right. Okay. Well, thanks for being here, Gary.
Yeah. Thanks, Jason. Appreciate being here.
This is Jason Kanigan from Cold Start Tech. Thanks a lot for listening to this episode. I hope you enjoyed it. If you do want to get email notifications of upcoming episodes or episodes that have just been released, and maybe a little news sprinkled in here and there, you can sign up for email notifications at coldstartech.com/MSB. That's short for Make Space Boring. That's another little show that I do. It's once, twice, 3 times a week, something like that. Anytime there's news or an update on who I'm meeting and what I'm studying in the space field. So you can go check that out. On the YouTube channel, I can do something that I cannot do on Anchor for the audio only side of things. The YouTube channel allows me to have playlists, and so you might want to go to the channel, the Cold Start Tech channel, and check out those playlists, because you will find you can go down a rabbit hole basically into several areas like space law and policy, small sats, and I think that's a lot easier than trying to scroll through 130 episodes or something like that, looking for the thing that you want. So I recommend going and checking that out. And remember, if you're ready to take your space business to the next level, or you're a VC looking for deep and very valuable insight into a space company you're looking at investing in or investing further in, come and talk to us. Thanks for listening.